Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Nur Anis Alia binti Wan Mohamad Zailani. Metric number CE190192.
And my name is Tharnisha over Sithanathan, and my number is CE190099.
From group A 5.4. So today we will explain about chapter 4 AC single phase 2-pole synchronous motor. So in this slide we will explain about next group member roles, introduction, connection of the experiment and synchronization of procedure. Next. Okay, so this is our task, the divide by 2. So for introduction, Tharnisha. Activity 1, Tharnisha. Activity 2 and activity 3, conclusion and minute of meeting is me. Report editing and compilation, Tharnisha. Video presentation, Alia and Tharnisha. And video compilation is me, Alia. Next. So, in this chapter 4, AC single phase 2-pole synchronous motor lab session, I will explain a bit about this lab. Basically, there are two types of AC motors which are synchronous and asynchronous. In this lab session, the motor used was AC single phase synchronous motor. Moreover, single phase synchronous motor is most likely to operate with a constant speed with low efficiency. Main application of single phase synchronous motor is in radio communication installations, improving the electrical power factor, compressor and synchronous servo system. Furthermore, in this laboratory session, the main aim was to perform synchronization of the motor and conduct the variable excitation test for the two pole of AC single phase synchronous motor with no load situation. So next, I will pass to my partner Tharnisha.
Thank you, Alia. So I'm going to present on the function of brush and brush shoulder. So carbon brush and brush shoulders are one of the fundamental parts in the operation of electrical motors. These elements act as an electric connection between the fixed and rotating part. So brush holders function is to provide safety and stability to the carbon brushes, while the function of brushes is to conduct electricity of the individual segment. So as they rotate from brush to brush, this also allows the motor to turn in one direction at a speed determined by the number of windings in the armature. So next is the connections of the motor. So as we can see here, we have the components of single and three-phase measurement, rectifier or AC wattmeter ammeter, DC wattmeter and ammeter, variable AC and DC supply, universal power supply, DC variable speed drive, shaft and also utensils. So as you can see in this diagram, the red wire represents the live and while the black wire represents the neutral. So we can see that these wires are connected to each another for the synchronization procedures, which is to obtain a synchronous speed of 3000 rpm. So as you can see here, the synchronization procedures are: first of all, the operating speed of synchronous motor have to be calculated by using the formula of N, or operating speed, equals to 120 times frequency divided by the pole. So for this experiment, we use 50 Hz for the frequency and the pole of the motors are 2. So we will get the synchronous speed or operating speed of 3000 rpm. Next, the drive machine was to be switched on and the shaft speed was set to 3000 rpm as calculated in reverse mode, while the AC single phase supply up to the stator windings was switched on by adjusting the voltage level to 135 volt. Next, the synchronous motor rotor DC supply was then switched on and the current was adjusted to 2.5 ampere DC and the motor was made sure to synchronize and run steadily at the synchronized speed. Next, the drive machine was switched off and also the shaft will still remain driven as it is coupled to the synchronous motor. Then, for the AC single phase motor was not a self-starting motor, therefore the drive being used in order to start the motor while be synchronized and run with the synchronous speed. So that's all from me. Thank you for watching.